Good morning, everyone. I'm going to get started. It is 9:10. I have been sending a little bit of messages and saying hi to everyone, but I want to say welcome to this day, to Friday. Happy Friday to everyone. I'm glad you made it the first week. We are going to be using all our 50 minutes today and finish up the discussion we started on Wednesday on the topic of what is data science. And what we have today to cover is a little more than what we had done on Wednesday. So I want you to be completely focused and paying attention to what we will do. And we'll use every single minute of those 50 minutes we have. Before I get started, I want to say a couple things. I was very happy with how you were interacting last time because we are going to be many and we don't necessarily have a chance to all speak. We're going to be using the chat feature quite a bit. And so every time there is a discussion that I would like to happen, we will be using the chat feature. And for that reason, I want to remind you one thing I did on Wednesday after the class was over, looked at the discussion that happened on the chat session, both for the warm-up question and for the things that were subject of the discussion. And I like that word chat analytics. So you've seen these analytics being attached to very many different things, whether it's sports analytics or learning analytics or anything like that. But chat here, I meant the chat feature that is on Zoom. And I didn't do any deep analytics on it. I just eyebrowsed and saw what you had to say on the two questions we had. One was on when you thought computer science was born, and the other one was on the positive side effects. And so I wrote a few things, but I like that word. It sounded good, chat analytics. And so I'm going to have a warm-up question for today. And I think if you have taught for a while, you might have seen some words that have made it into our vocabulary. Things that are born from technology, things that are born from things around IT, let's call it, or the thing that we are in now, the information age. One good example would be to Google. Now you would say, I would Google somebody, you know what you mean by that, but it has made it into our vocabulary. So the question I have for you today, for a warm-up question is, what is your favorite tech-born word? It could be a verb, it could be anything like that, but I want you to go ahead and participate on that one. This will be our warm-up question today. So warm-up question 1, what is your favorite tech-born word? And you can go ahead and tell me what that one is. I told you Google is one example. It's not necessarily my favorite one, but it will actually show up in our discussion today. But you can come up and tell me what that one word would be. That's something that has made it into our vocabulary, that people would understand what you mean by that. I'll FaceTime somebody, you could say, and then now everybody would know what that would mean. So let me give you some 30 seconds for those who have joined late to get to answer that also. And I will know when it is roughly about, we are 70 of us now who have joined. I know there will be a few more that may come, but I would know roughly when we have gotten in there. So that will be our warm-up question for the day. Okay, these are all nice ones. So you will get the chat analytics on this one when I am done with the lecture today, sometime during the day. It would be late in the day, but I hope to get to be able to do that. All right, while you keep doing on that and pick up your favorite tech-born word, I want to come to get started with what we want to do for today. And I'm going to come here and start by pointing out one thing. We have not started the discussion yet. I have done the survey, the initial survey, the pre-course survey, and almost everybody in the class has completed it. I think there are 4 or 5 of you who haven't yet had a chance to do it. So if you are hearing me now, make sure that you do it. There are many things that I want to capture there, but one of the things is the need for a tutorial on R, and there is an overwhelming need. So Helen and I have decided that we will run it. The topic for next week is R. and so we will finish what is data science discussion today, but what the topic for next week is going to be R, because we want to get have a tool in place, and some of you have some knowledge, some of you don't, and so we will have the lectures as well as a tutorial on R. The tutorial time is difficult to make everybody happy. I tried to look at what classes you're taking through one of those survey questions, and there are very many variations. And so it's very difficult. But I think overall, these are the 2 times we have. Our classes are Monday, Wednesday, Friday. The R tutorials, there will be 2 of them. One of them will be on Tuesday, September 1st, and the second one will be on Tuesday, September the 3rd. Both of them will start at 3, and they would go to up to 75 minutes, but we have written it as 90 minutes here, so an hour and a half. And so they are going to be very important to complement the lectures that we would have, the discussion we will have in class, but also to have for you to practice. It could start from basic things, having to install and do things. So the art tutorials for next week are settled, and the days are Tuesday and Thursday, and I very much encourage you to take advantage of that. They would be available afterwards, the slides and the recordings, but I would very much encourage you to attend them if you need them. It is going to be a course where you will have to pick up things and you don't have time to lag behind. So I would, anything that you would need, any reading or any assignment, you make sure that you do them as we go along. And the information, the meeting information for this will be available on Blackboard, and so watch out for that. And probably after the lecture today, that information will be sent. While I talk about this one, there were a couple of questions on the chat before the class began. And one of the questions that I got was the reading material for this class, and I had 2, was posted and somebody didn't get a chance. So I want to hear, and it could be a yes and no on your feature there. So you tell me, how many of you did get a chance to actually read them? Because I think it has the login information is coming depending on the browser you have. If it was too heavy to load it, it may ask you to log in to where it is located. If you had fine, then you would see it. So for some of you, it might have worked just fine. For some of you, it might not have. The question I got on the chat session tells me there was someone who had struggled with what that they were forced to log in. So let me see, how many of you did successfully see it? The question is not necessarily whether you have read it, but whether you had access to it. So let me see the yes and no on this one, and see if I can assume that this will be fine for other times. Yes, okay, so there are many people who are saying yes. And so what is being, all right, so this is even better. So the yes and no, I was asking to tally and see if I see, but this is even better. So what I know is that it has worked for those of you who had, I see. So Brit had to go somewhere else to get it. I don't know, and so it might have to do with size, but I had posted them and they were important for the discussion we'll have today. And I will assume that at least those of you who were able to see it had a chance to look into it, to read it and get started with it. Okay, so we'll start now. What are we doing this week? We are doing more of a reflection, if you like, more of an understanding at a high level what this discipline is, what this area is, and tried to see 2 things last time. So we kind of saw the hype around it and then going past it, and some very good discussion in class about why it is happening, one of the things that enabled it. And there are 2 things left for us to do today, and that is to look at a few examples, and those are the reasons why I had those articles, very substantive ones. And I also want to talk about skill sets needed, and this one is relevant to many of you in many ways, immediately for what you're doing now and down the road in your careers. We had seen this slide. This one is more pictorial, at least location-wise, what kind of things at what intersection data science lies, and we had it and we spent some time to it. But the reason I'm bringing it up now is because I call this one example 1 of the things that I wanted to discuss around this landscape of perspectives, and we will leave it there. So the other 2 are the things that are based on the articles I asked you to read, and so we'll start with the first of those 2. So let me first say, there was another question I got on the chat when we began, that you wanted me to, or you wanted to have the slides ahead of time so that you can take notes on them. And I would like to make them. And so most of the time I make the slides because there are things that I would like to discuss and so on until the class is ready. But I can always make them half an hour or an hour earlier and put them on Blackboard so you can follow along. So prompted by that question, I did actually post it on Blackboard right before we go. So if you are that kind of person, then you have it. You have it on Blackboard, and so you can do it. My preference would be, in general, the slides are excuses for discussions. They are, I will highlight points there, but more of the discussion that will happen through the way I talk. And so you can ask questions and so on. So the best thing might probably be to have your notes taken on paper. But I also know there are things that you want to maybe mark there. And so it could be a good way to do it. So if you are inclined of that type of person, then the slides are there. So we have two articles to discuss. And the first one is an article that appeared in ACM. ACM, for those of you who don't know, is an Association for Computing Machines, is I think what it is called. But it has now, nobody knows what ACM stands for what if it was to be spelled out. But it is a society. This is a society for computer science and bigger things around it. And it has got many journals and many conferences that happen around it, but the flagship journal for it is called Communications of the ACM. So usually when articles appear there, there is something big about them. And this one is an article that has influenced my own thinking about how you may approach what data science is. And if you have read it, you will notice that some of the way in which I have constructed the syllabus and some of the way I describe the course has got something that would come from this paper. So it's an excellent paper. And I have assignment 1 out today, and I will talk about it when we just to finish this one. But one of the things that it will make you is read this article. I will assume that you've at least browsed through for the purpose of this discussion, but you will get a chance more to read it also. And so what this article tries to do, and this is written by a person in the business school at Columbia, is define and try to show some connections with other things and some of the skills that are needed at a much deeper level than what the cartoon diagram that I showed you in the beginning showed. So I mean, I'm going to, and then there is a link to this on the slide, so that will take you, and the soft copy of this one is on Blackboard already, but the link here will also take you there, and it is online, available online. So there are 3 major points this article makes. And if you are the kind of person who wants to follow along as I discuss, you can do it, but the points are summarized there. And these are the key insights, as the article calls them, that appear on the very first page of the article. So data science is the study of the generalizable extraction of knowledge from data. And last time there was a question from Pratnia, I think it was, why do you call it generalizable? What I mean by here is that you are looking at data, you are trying to deduce information from it, extract knowledge from it, but you're not just describing the data that you are looking, but rather be able to extrapolate, able to generalize things that you have not seen. This is where machine learning comes from. This is where prediction would come from. And there was another question in the chat today, how much of this class is about machine learning? 40% or even more of it is machine learning. And so this is where models would come, and you try to build a model that would predict, that would enable you say something around a data point that you haven't seen, but you will be able to reliably predict with certain accuracy on where things would be. This could be a question on classification. This could be a question on predicting numerical values, which is what regression would mean. So generalizable extraction of knowledge from data, that is one of the things that this major article points. The other is a common requirement in assessing whether new knowledge is actionable for decision-making is its predictive power, related to what I just said, not its ability to explain just the past. Predictive compared as opposed to descriptive. There is value in doing descriptive work. There is value in trying to find patterns. There is value in trying to see how things would cluster. Some of you who have a background in physics, for example, may find out that there are things that are much more about understanding how things relate with one another. And so you have found a pattern in the data. You have found things that would, clustering will be a good example. Or if you are in the business world, whether you wanted to see how your audience would be classified into different groups, not necessarily to predict, but just to have to describe them so that you can say, this is this demographics, this is that demographics. Or if you were in biology, you wanted to see relationships and just looking at what that one is saying in a visual manner, in a manner that tries to discover what is related to what is descriptive. There is value to it, but the decision making, the predictive power is a much more important thing for healthcare, for business, for engineering, for design, for those type of applications. So it is another point this article tries to make. The third point is about what does it mean? What fields are needed? What skills are needed? And this is something that we'll come back to and discuss in the later portion of this discussion. And this one has become a way in which you can say, the variety of it is neat, and sometimes you have explicit references to different areas. Sometimes you have lumped together way of describing them. But here is one of the points this article makes is the need for having to draw skill sets from very many different areas. And no single person will have all of this in equal depths. And so there will be a rational expectation about what we can expect of ourselves and what we can say we are having a working knowledge on, and something that we can say we have an expertise on. So these are the major points this article makes. There are many, and you will get a chance to reflect on a few things when you read the assignment, and so the questions are. One question you may ask, and you might have asked it this one way or another. Many of you might have asked it. We have this word data science, and the word in this phrase, data, has been a subject of study for very many years. And that field is in fact called statistics. There is a field called statistics that studies data, analyzes data. And so many of the things that we say now, there was a discipline already. If that's the case, then why a new term now? And this article starts by saying a crucial point that I completely agree with, and I see it every time in what I do in my own research. The reason, probably the best one-word reason you would give for why we need a new term, if not anything else, would be the nature of the data we look at. And that data, the nature of the data we look at now, is highly unstructured. Traditionally, if you look at it, if you remember your stats, courses and so on, you would describe having more or less like you have a table of some kind. So you've got rows and columns and you deal with them, you find the average, you do standard deviations and things like that. But what you have is structured data. It could have one type or another type. It could be, you can characterize it in different ways what the nature of the data is, but it was structured. What we have now, and increasingly so, is unstructured data. What do I mean by that? You've got things that are text, there are things that are video, there are things that are emails, there are things that are around that are left for you. So the abundance of data that we have now is not just about volume, and those of you who are taking big data class may have all kinds of names and V's around them and things like that. If you find that useful, you can use that. But more, maybe plain way of saying it would be that it is highly unstructured. And therefore, we need a different kind of science. Therefore, we need something that would get us closer to the data and live with it and manipulate it and work with it. And so here is a chart, and this article appeared in 2013. So some of the numbers that you see here may feel a little bit older, but the point this one is trying to make is how unstructured data and databases will be, structured data, and email has been growing. And you can see how much the last maybe 5 years or so since 2010, and these are in petabytes, by the way, and the article has got actual numbers there. You will see that there is a much larger growth in unstructured data, and that itself is a very good reason for why we need to have a new field or a new science in a way. Let me invite you, and assignment that is out now will make you read that article, and there is a concrete example, a case study on healthcare, and there is some discussion around how you would want to say what you can expect of models. Models as they are used in science, those of you who are in physics or to some degree in other disciplines also know what a theory means. And unless you see some causal relationship to describe something, you will be deeply unhappy. You will not call it a science, because then there isn't any model that's trying to find what the reality is. You would be, in some cases, challenge it to abandon that type of thinking when you have become more data rich, because then you may say, and some people take it extremely far, to discount the value of theory, the value of model, but then rely on what the data would tell you. That can take you only so far, but there are some people who would argue. So that article makes a distinction between that type of theory, that type of causality, and what you could say when you rely entirely on data. And that article also talks about the difference between causality and correlation, which we will come to many times. If anything, by the end of this course, I want you to be able to literate people, and so don't confuse something that is correlation only and try to make as if something has caused another thing. We'll cite a few examples when that is done in a bad way. So those were the things I wanted to talk about the first article. The second article, and which is not asked for you on your assignment, but you will come back to it later on, appeared also in ACM. It appeared 5 years later than the first article that I told you, and I spoke only a few minutes because that's what we have now, and you will read it. This one comes 5 years later and tries to talk about realizing the potential of data science. So in some ways, let's call that 2013 article the time when somebody tries to kind of articulate what the field is and put some names on it, and then we've got all kinds of flurry of activities that have happened nationwide here in the US and to some degree internationally also. And so lots of activities happen, and then people would try to sit down and then say, what is the curriculum? What is the field? Which department should it belong to? How can we harvest, the potential of it? National Science Foundation was big on this. Many of you who are graduate students would have, your advisors may have had, grant is funded, and all this thing around data revolution has made people to come back to the drawing board and say, if this is a discipline, where does it live? How can it be realized? And so this article was a result of a workforce, a task force put together by people and funded by NSF. And so they sat down for a couple months, discussed and so on, and so come up with a big report. And this article is a summary of that report. And so what will you want to take away? Why did I put it there? First, I wanted you to see why I asked you the warm-up question last time. When do you think was computer science born? You were very kind, so you gave computer science an older age than what she thinks she is, and I'll call her a she. So it's more like if you were to say, here is what this discipline would have in it, here is how it is defined, that will be the 60s. Much like that, I think I would call what we are living now, that time where you would say, if data science is now a field, and we realize that it has got a thing that will make you have different pieces come together. But if you were to define a curriculum around it, what would it be? And so 2010 or 2020, 70 years later than computer science was born, there is now a field called data science. You may put it that way. And sometimes 10 years from now, if you become a professor and you do a chat question, you would say, when was data science born? And so people may point to this time. So what this article does is to see it this way. Instead of being just interdisciplinary, if it is to be a discipline in itself, what distinguishes it? Where should it live? What are the current practices in the US, especially in the US, because this was funded by National Science Foundation. That's what this article does. So I've covered a few points here. There is a link to the article itself that you can come back and read to. And there is also a link to a video that's just a short one that you can watch when this class is over. So what are the key insights? Just like I did with the Dahr's paper article, I have 3 points summarized here. Data science can help connect previously disparate disciplines that you will see more and more of it now. Many of you might have been on that boat, and you might have seen interaction with other disciplines. You might have taken classes in other places. That's the reason why you are coming here. And you would see more and more of this type of connections between disciplines that were otherwise disparate. There is a broad set of areas, and here is, a list. I'm looking at the second point now. Data-focused algorithmic innovation in machine learning. These are some of the broad areas that this encompasses. Data mining and use of data for discovery, collecting, organizing, stewardship, and preservation of data. Those of you who come from places where there is lots of things around collecting data and how it should be kept, how it should be, the stewardship around it is an issue for you. And so you may appreciate that point more than others. Privacy challenges, that is a huge concern. Some of you have indicated that the ethics and privacy issues that I would just have a lecture on at the end is something that you would want. And the pedagogy to support it. This is the areas that it lists. If you are a curious person and try to see the discipline that you study, and one day you will be in industry, you probably are already in industry, you may see something that you could always have a gap or a clear distinction between what happens in academia and what happens in industry. Data science is interesting. It's interesting because it actually is something that, in my view, has to a large extent been driven by industry. And unfortunately, it also is a place where much of the people that we know would be drawn into. And so the academic aspect of it is not as strong as it is on the commercial side. Think about the big companies, and think how many people are going there, including my own PhD students who would end up going to these big places. So if you think about this gap, there is an opportunity to be had, that there is better interaction, but also there is something that would say, makes it different than others. You would not see that in physics or in biology or in chemistry. I think you see more of this in fields around what I would call data science. So this article has a very nice view of the bigger things than just machine learning. Gordon asked me how much of this class is in machine learning, and I said 40%. If you look at the topics we cover, it will be a very accurate estimation to say that 40% of the class is machine learning. But there are other things. We'll touch on them. We have just one course and one semester, and we're not going to have to be able to cover everything you need. You probably would need, a good set of courses to be able to have all of this. But this one actually does put things in perspective and tries to see data in the form of a life cycle. I talked of being born as a discipline. Computer science was born this way, data science was born, and so they grow, these fields and so on. And I think it is a nice metaphor now to see, this is a different one, where you can see a life cycle for data, which also means that there is a time when it probably would die. And so there is a time when, the data gets born, and so it lives, and so there is an ecosystem to it. So I have quoted exactly what this article says about the fact that data never exists in a vacuum. You are sophisticated people, and so when you would read on your own, you would add your own footnotes to what these statements would mean. And so there are so many of you who would have your own research, your own thing, your own perspective, and that's a good place to say that there is room for domain expertise to be a significant player in data science. It's not just about what you would do with your machine learning model. It's not just about how your coding skill is and getting scalable performance out of it, but you also would want to have the right questions to be asked. You also would want to be the person who would want to interpret the data and relate it back to where it came from. And so it never exists in a vacuum. Like a biological organism, data has life cycle from birth through an active life to immortality or some form of expiration. And people would struggle a lot with this part, by the way. What do you do when it is no longer needed? How do you, keep it alive and when it is needed, and then things that is not anymore active or is mortality of it is important. Also, like a living organism and an intelligent organism, it survives in an environment that provides physical support, social context, and existential meaning. I'm going to let you think about this one, what I just read, and we will walk through what we see on the right. But let me, because I trust you can process multiple things at the same time, let me tell you about something that would mean something that you can relate to. If you think about markup languages, XML, HTML, these are markup languages, you would learn them. And so there is presentation. So there is something that would make something look on a browser, for example. That's what markup language would help you do. There is something that you learn as a language to make something presented to you. And people have formalized this, people have learned this, and people would use them. More and more, that is still there. More and more, what we see now, and those of you who have taken a class on AI or maybe have something natural language processing type of background, you would see not only presentation issues, but data, something that is also intelligent. Something that would make, when you, interact with a piece of software on an app or you're on a browser, it's not just about presenting something with a markup language, but you embed in it something that would make it decide and help you do. It could be an action that it will make you drive into, or it could be something that would trigger you to do something. We have come to a place where now there is a need for having to embed intelligence in the data or in the software that we write, or in the thing that we interact with. So the context in which you live in, and in decision-making and intelligence, there is that point I wanted to make on what is written as a sentence on the left. So let's look at now what is written on the right. And this is a nice summary, as I said, and you will come back to it. And it's not a matter for me to walk you through it now, and we are done with it. The article has made this particular job in a good way, I think. So we've got data. We start with the process of acquiring it. And that has to do with things related around its capture, things about its generation. Many of you would now relate very much to it if you're working in a lab where you generate this data, or if you are a little bit old-fashioned and you have to create surveys to say what people are thinking about questions that you have to them, or you might be thinking about devices that have enabled you acquire it, and this could be PMUs on a grid, or other devices that are mounted in a home, or simulations, and I'll come back to that. That is the acquire part of it. So the data is being acquired. This is where you get the raw thing. Then you need to be able to clean it. You need to be able to organize it. You need to be able to filter it. You need to be able to annotate it for it to be useful. And by useful now, I am thinking about being able to predict, being able to analyze, being able to build a model around it, being able to do that intelligent decision I just told you. If you are doing a company and you're doing a self-driving car, all of this thing that you have done now is going to make you steer a wheel. This is going to make you do something to drive. It could be a vehicle that you're driving, or it could be a plane that is being flown, or it could be something smaller. It could be a simple robot that is happening. So there was something sensed, something acquired, something gathered, and then cleaned, and then you are using it to do this. We're still working on data. And so the fourth part of it will be about publishing it. I, on the side, talked about XML and things like that have to do with appearance, without how to for them to be presented, and so publishing it, sharing it, workflows, dissemination, aggregation. We will touch on some of these things as we work with, for example, data wrangling. Part of the things that are around cleaning, part of the things that are around publishing would come around things that we would call data wrangling, working to have to do with different databases, for example. And then the preserve and destroy aspect at the end. Where do you store it? How do you store it? How do you store it so that it is fast to access? How do you store it when things that are important are coming to the front and others that are not needed are coming to the back? And so there are some keywords. So I think this chart would invite a lot of things that you want to do. As I said, it's not a point to just walk through them now. You'll come back and think about them later on. All right, what I have shown you, or the people who have written this report have captured through this image makes you feel like these things live in isolation. So that these are, solo things that are there, and you can, walk through them like this. Traditionally, what you would see is each one of these has got a discipline on its own. So for example, if I was going to think about how to generate and use data, that will be where the domain scientists would live, the biologists would live, the physicists would live. They are the ones that would generate, and the computer scientists would do on the platform issues, the performance issues, and mining and the organization of it, and then the physical process of acquiring and the instrument control and so on usually would be something that you would put in a field like engineering. And the part that has to do with analyzing the data and trying to work with it would be the realm of statistics. The curation, the preservation, and things like that would be the domain of information science and library science. So you see that there is this solo divisions that exist, but what it also tells you is there is a more and more need for having these things to come together, and the things that would require their integration, the thing that would require there's the interdisciplinary or the merger of these things and being combined. And so the scientific communities traditionally have been in isolation in some ways, but what it requires to the harvest of this and a good use of it would require all of it put together. And that is a challenge. And that's what that article talks about. Where should it live? Which department should house it? Or should it be, in fact, within one department? Or should it be some other mechanisms for doing it? So read with those things in mind, that article back when you get the chance. All right. I'm going to have a blank slide now for a moment. And I think the discussion I had so far was busy with the slides, hopefully with what I say. And as I told you, the slides are not going to cover everything you need. The discussion is more we would have. And in this particular case, discussion meant more like me talking, but feel free to, ask, unmute yourself and speak or take notes as you go. So I'm going to talk about something now that would make you do assignment 1. So assignment 1 is out, and it will help you read the first article, and it will help you do something around yourself. And this is what I wanted to tie it with. There is a number of different ways in which you can describe and make concrete what skill sets are needed. We have indirectly talked about them through what I have discussed so far, but I'm going to have a simplistic way, a list of things that would say, when you say somebody has data science as a background, what are the skill sets needed? And I want to think of it as something that you would call a profile of yourself or anybody else. So without any bias, you all know, so I'm going to make a confession. I'm a computer scientist. I belong to a computer science department, or electrical engineering and computer science together. And there is no ambiguity in how we have described so far that one of the skill sets you need in data science would be computer science. But let me be clear by what I mean here. Not necessarily clear, but the loose definition of here. Here is what I mean by programming skills. Here is data organization, things around performance, high performance computing, programming, data structures, algorithms. Let's put them all together in one big bag and call it computer science. The other skill you would need, or anybody who has data science skill, would be math. And that doesn't require a whole lot of explanation. But I want to make a distinction between math and statistics for the purpose of this discussion now. And you would know what I mean by that. So the thing that is required around linear algebra, every time I say it, the thing that requires about something that is mathematical in nature, differential equations, although we will not do them in this class, or, rarely in anything, but there is a need for having to know, for example, what it means to have a derivative of a function, an optimization, that type of thing. That is a lot in machine learning, by the way, and sometimes people may underestimate it, but there is a lot of math that happens there. Stat is obvious. I'm going to call machine learning separately, and so this is probably going to confuse someone, they would say machine learning is computer science. I am making a distinction now, not just me, but the profile that I'm going to show you, a simplistic way, makes that. And you would understand what I mean by that. Here you have something that is about building models from data and learning from data, and not necessarily about the other things that I told you, although there is a very big gap. Intersection with what would be called computer science. So I'm going to go through the list, right? We've got 4. Domain expertise, we had to make a case for this one, so no need for spending more time on it. I'm going to separate out data visualization from everything that I have said so far. How do you best visualize data to, especially to not just to understand the data, but for somebody else to understand what you mean in a quick way. Data visualization is a skill, and that would be one of the things that we would need. So I've got 6. And the last one you would need, and a good data scientist would have to need to do, is be able to communicate and presentation skills, probably more than many of the other fields that we have worked in and identified ourselves with. This will be something that you would need more of, in part because you work in teams. So we've got these 7. So I'm going to show you one of the things that assignment 1 will make you do. And this is a presentation or a way to summarize something that probably has got practical utility. And this one is taken by a picture from a book by my cell phone. So that's why it looks not so very nice, but it is a bit dark towards the end. What you have here is the skills that I have told you. I've mentioned 7. Data visualization, machine learning, mathematics, statistics, computer science, communication, and domain expertise. These are the 7 things that are listed on the horizontal axis. You see here is bars. And think about the vertical axis as a relative scale. So the thing that you are the strongest at, and let's call it a 1 or 100%. And the other ones would be relative to it. So what your skills are in statistics compared to computer science, for example. This particular profile is done by the author of the book I told you last time, doing data science. And this is, the author's name is Schutt, and she's a PhD in statistics and worked in industry for many years. And so this is what her profile looks like. Yours will look completely different from this one, I'm sure. And everybody has got their own. There isn't anything right or wrong. People have got different skill sets, different combinations, different profiles. Nothing is going to make you better than another person, but people have difference. And I want you to make one of your own, where you list the things that are these 7. And I have explained what I mean by them. So you would know roughly, and you would know where you are the strongest at. And by strengths, I mean your body of knowledge, whatever you know now. And there are things that you would want to grow. So assignment 1 will make you do your own data science profile, but it will make you do 2. 1, the way you are now, and the second, the way you want to see by the end of this course, so that you have a goal for yourself. And so the details will be there, are in the assignment, but we will make a data science profile. I find this one a convenient way, a good way, if you were to make up a team and you are going to set up a project, for people to know roughly where they belong to, where they are good at and where they are not so very good at. And again, I want to be cautious about not saying good at and not good at. There isn't anything wrong by having a lack of computer science in your background, or the other way around. If you're the strongest in computer science and your knowledge in data visualization is low, nothing wrong. That's how you are now, but that will be your profile. All right, I'm going to spend a little bit of time now. We've got 5 minutes, and I'm going to go a little faster. And because you have the points on the slides, I'm not going to be worried. And I came back at 2 significant articles that we discussed, and you can go back and read them. But here is something that I kind of pulled out from the very people, the person who wrote this data science profile in the book, what they think of what a data scientist is. And I want to show you 2. One, what a data scientist looks like when they work in industry, and another, what a data science looks like when they are in academia, like myself, or like many of you now. Maybe a year from now or 2 years from now, you will be in a different place. But in industry, what would it look like when you say somebody is a data scientist? And because I have only 5 minutes left, I'm going to go faster, okay? And because you have the slides, you can go back and look at them. In industry, a data scientist is someone who knows how to extract meaning from data, interpret the data, which requires tools from statistics, machine learning, as well as being human. I like the fact that they actually include the fact that you're human, because sometimes that's forgotten. A data scientist in industry is a person who spends a lot of time in the process of collecting and cleaning data. This process requires a number of things, including persistence and some software engineering skills. She will be the person who would turn the data into be able to have exploratory data analysis and combines visualization and making sense from that data. And you will see when I describe this one, it sounds more like somebody is trying to take you from the beginning to the end in a way. And we will come back to this data science process in a more formal way in one of the lectures on week 3. But she will be the person who would find patterns, build models and algorithms, and with some intention of understanding product usage. In industry, that's important. People would use products, a web browser, for example, a recommender system, and build a prototype that would actually get back into the product itself. She may design experiments to see how customers are doing or how people are using it, and that could be coming back to the decision-making process. And she will need to communicate with whom? Sideways with team members, upwards with leadership, and sometimes front towards people who are going to be using it. So I have used a metaphor now. You're communicating sideways, you're communicating vertically, and you're going to all 3 dimensions are there. And the people that you care about for you have products are people that you would, user-facing product is what they would call it in industry. This is what a data scientist looks like in industry. I know I've gone a little bit fast on it, but you will come back and look at it. If you are in academia, you will have one bullet point, unfortunately. I'm going to summarize it in just one sentence. And here is a place where you would see both the diversity, not only of generally the field, but also this class. So in academic setting, you are a scientist. You could be trained in social science, or you could be trained in biology, but you have an academic discipline. You work with lots of amount of data, and you have to grapple with computational problems, both posed by the structure, the size, the messiness, the complexity of the data. And that is the place where people would start to talk about the same things, no matter where they are coming from. I have had this conversation so very many times with so very many different people. You would be dealing with something that was generated by an instrument, an image, and you are a plant biologist. Or you could be somebody else doing an X-ray image for a patient and you are in the health sciences. Or you could be a geologist and you are capturing something that has to do with soil and landscape and things like that. What is common in all of those is that you have got things that have to do with structure, size, and complexity that is about data. And there comes the common language. There comes the common thing. But I have written in green the thing that would make you pay attention closely, because you, at the end of the day, want to address a real world problem that you are facing. If you were a biologist, there was a driving biology question that you wanted to get answered. If you were a geologist, same thing. So getting to solve the data problem is only part of it. And that's where your commonality lies with other people. But the question that you wanted to answer, the thing that was driving what you were doing remains there. And you're the only person to be able to answer it in a good way. That is where your discipline comes in. All right, that is what you look like if you are a data scientist in academia. I've got 2 minutes, and I'm going to ask your patience, and I'm going to finish off by telling you something that is more personal in a way, or more related to my own growth in terms of research areas and things like that. If you've been in physics, for example, you would know, and you've heard this so very many times, the 3rd pillar of doing science, and that was simulation. That is when these terms called computational science and engineering got born. If you are in the Department of Energy, I know there are a couple of you at PNNL, you would know this term. So there is theory and there is experiment. These were the traditional ways to do science. And then came supercomputers. And then came things that would enable you to do computational things, so that now you could rely on simulations to do science. And that is what computational science and engineering was. So we had these 3 pillars. And we had made a lot out of it. DOE has the SciDAC program, the Scientific Discovery Through Advanced Computing. That was based on simulations and computational things. Then now, based on that one, people have called something called the fourth paradigm. And that is also about doing data science, but it is not based on simulations, but rather by the massive amounts of data we have around now. Those data could be a result of simulation, perfect, fine, but they could also have come for some other reasons. We've collected them through sensors, we've collected them through some other means. And what could we do now with that? That's called the fourth paradigm. And that's, I think, a very nice place where you could see data science also. That was my plug. If you got what I mean, great. If not, talk to me some other time and we can talk more about it. But this will be a good way to see the role data science plays, especially in things that are around science and engineering. I'm going to leave you with a slide, and I've finished, and it is 10 o'clock. We didn't break out for breakout rooms today, but what I want to leave you out is with a slide. This is not mine. This is taken from a book by Barabashi on a network science class that I teach. But this is all the companies that we see, not all, a good number of them that are based on, this is places where you would, some of you end up working, or maybe you would have your own startup someday. But this is a nice presentation of all the things that are around, or mostly data-driven type of companies. And so the economic impact of having to do data science has become huge. These are numbers that are old. They are 10 years old, but you can see some of the figures there, and it is staggering. And so for those who are tempted by this to go to industry, welcome, go do it. Those who are genius and have your own ideas to start up a company, go do it. And those of you are in industry, in academia and want to figure out things so that we make social good, or you make scientific discoveries, you're welcome on board. And so you can say, but I wanted to leave with these slides. All right, I'll stop here. It's 10. I hope you have followed me along. That's great. And so let me give you a chance to ask for quick questions if anybody has. I have been trying to monitor the chat session, and I see good discussions around. I'll do my chat analytics and tell you what I find out in a quick email via Blackboard, but let me see if you have any questions for me. Did you follow me along? Okay. All right. All right, then I'll stop here. I'll see you on Monday. Assignment 1 is out. It will be due on Wednesday, and you will have fun doing it, and it will be to your own purpose. All right, take care. See you on Monday.